All right, let's get started here. We are starting a new topic that is the model view controller and few design patterns. So to explain all this, I'm going to give you a demonstration of a drawing program, which I'm sure you have seen in the videos for this week. So seeing the demo and then actually seeing the code together would be a good way to understand the architecture. So let me first start the drawing program. I think it will be better for me to share the desktop. So let me go ahead and do that. All right. So let me go ahead and start the drawing program. It is available on the D2L site. There are two versions of this program. I have uploaded only the FX version. There is a swing version also because we want to have both versions in the book, but I am going to cover the FX version here. This is the first version, Class Project 3 version 1 FX. So there is a main package and it has this drawing program.java in it. So let's see how it functions. I'm right-clicking and starting it here. What's going on here? All right. It's not doing as I wanted it to. I wanted the, okay, if that is the case, I'm going to stop the share and I'll just show the program to start with and then, all right. This is the program. When it is initiated, it gives you a window. We will call this the button panel, and this is the drawing panel, or we can call this the control panel perhaps. And it has a set of buttons here. Line draws a line, label allows you to create multiple labels, polygon allows you to draw a polygon, save saves the drawing, open retrieves the drawing, undo and redo, you know what they do, right? So if you click on line and move the cursor to this, you can see that it has changed its shape to a crosshair. I need to click on one end line, one endpoint, and then when I move the mouse, it shows the line, and I click on the other end line, and then the line is drawn. If I click on polygon, I click one vertex, click the next vertex, click, click, click. And at some point, I decide my polygon is done. Then this is my last vertex. And I mean, the one that I have, this is my last vertex, okay? I don't have any more. Then I right click. I'm going to right click and the polygon is drawn. Label, I click here, I type, and then that is my first label. I can create multiple labels now, just for a variation, that's all. I can click and keep on typing more labels. I can use backspace to remove things. And if this is my last label, I can right click and then the label creation is over. I can undo these actions and redo them as I please. Okay, I can save and it will ask me for a file name. Let's say it is XXX. I replace it. I'm undoing, but let me go ahead and retrieve the saving, the file, the saved drawing. So it is under downloads XXX, I think. And I got my drawing back. Okay, so that is the program. A very simple program, but it has lots of interesting architectural and design features that help you learn many concepts. Okay, so let me close this share, or maybe leave it there for another minute or two. How do you construct a program like this? One way is to divide this into three parts. There is the drawing. So you can think of this as a collection of shapes. You have a polygon, you have a line, you have labels, you could have other things like circles, images, and so on and so forth. So they could all be thought of as a collection and stored in a class or multiple classes. Okay, so that would be one part of the program. Then you can see that there is this interface that lets you create shapes, does undo, redo, save, retrieve, and so on and so forth. So there is a set of commands that you can input. So there's a set of commands you can input. There is a set of shapes that you can store in this program, and the program displays the shapes. So I'm thinking in terms of three things. One is the shapes themselves, storing of those shapes, then the commands that I can input, and the third thing is the display. So the storing of this information is called, or the place where you store that information is called the model. Then we have input that is handled by some part of the software. There has to be some place where you handle the input, and that is called the controller. And the third thing is the display of the information, and that is called view. So we have three different parts of the program. So we can actually think in terms of three components. We have three components. One is, maybe this is not the best way to draw it, but anyway, let me do it that way. One is the model. Then here is the controller, and the third one is the view. So the model stores information, the controller handles input, and the view displays the information. So we are dividing the functionality into three separate modules. So at the very outset, we are saying, this is how I am going to design my program. I am going to divide this into three big parts. One is the model, the other one is the controller, the third one is the view. And this is an approach to creating systems. In fact, big systems. Our drawing program is not a big system, but we don't have the time to cover large systems in a 15-week course. So we have to take something small and then see how to use an architecture like this, model, view, controller, and that is called the MVC pattern, model, view, controller pattern. So you're kind of making a decision on the design almost at the beginning. As soon as we know, okay, we have a lot of input coming in, a lot of things to store, and we should be able to display things. You're saying, okay, let's use the MVC pattern for this. So we are dividing a huge system, a potentially huge system, into three parts: the model, view, and the controller. And then we will design these independent, more or less independently. And in the construction of each of these, we might use several design patterns and so on and so forth. Okay, so that is at a very high level. All right, but then there is the other aspect. When we say controller and view, what do we mean? I mean, the controller handles the input, the view displays the shapes, but they are really in a graphical user interface. We have you saw that window that with buttons and a drawing panel and so on and so forth, but that is really JavaFX code. So the controller and view seem to be put into the same place. We have a single window where you could type in stuff, you could click on buttons, you can click on the mouse, and at the same time, almost at the same place, you are seeing things displayed. So there is no real separation. But here we are showing two different things. That is a bit of a confusion. So let me write here, there is a graphical user interface in play. But the graphical user interface, if you think about it, that is a JavaFX or Java Swing or some other technology dependent piece, whereas handling of the input, handling button clicks, for example, what do you do when you click on undo? How do you get undo done? That has nothing to do with technology, right? How do you ensure that a polygon that you drew has been deleted? How do you undo that operation? It is not dependent on JavaFX or Java Swing or any such technology. It is a logical piece. So what we are going to do is we are saying there is a separate piece called the graphical user interface, which depends on the technology, but the handling of input through the GUI is done by a controller. So the controller is going to be independent of the technology that we use to construct the graphical user interface. Similarly, the view ultimately has to invoke API of the technology we use to construct the GUI, but there is more to displaying things than just the technology. We have to decide, what are we going to display? You might say it is things in the model, sure, but do you want to display everything in the model, or do you want to display only parts of it? So the view can make all those decisions. So there is a lot of logical stuff that is going on in the view. There is a lot of stuff going on logically in the controller, and the model is obviously just a collection to store the objects, add stuff, retrieve stuff, delete, etc. So that has nothing to do with technology. So we have a technology independent piece of software here. That is the model, view and controller, and a highly technology dependent piece called that is the GUI. So we are actually having 4 different big actors. We should be, ideally, we should be able to replace the GUI with another technology and still reuse all these 3 pieces here. Any questions till this point?
Just a quick question, Professor. Isn't GUI view, or is that something separate than view?
We are separating the GUI from the logical view. I can show you that in a couple of minutes. The thing is, the GUI, if you think about it, we had on the left side a bunch of buttons, and on the right side we have the shapes displayed. But in the same place, we also click the mouse, right, to specify a vertex. We type in things to say what the label is going to contain. So the view and the controller all seem to be in the same area. We can't really separate them out. So what we are saying is that is our graphical user interface. The view is the logical piece that says, let me draw a polygon. Let me draw these shapes that are in the model. And you need a lot of logic to do those kinds of things without knowing exactly how that drawing will take place. Similarly, the controller has to handle input. When you get a request to draw a polygon, how are you going to construct the polygon? How do you represent the vertices of the polygon, and so on and so forth? That is independent of how you actually handle button clicks or mouse clicks on the GUI. So we are separating the GUI from the MVC pattern.
So are you saying like view is kind of like another facade then to the GUI?
The view is another piece of the software that would use the GUI ultimately to carry out the task. Let me show you before we continue further, let me show you the code that might give you a little more insight into what is going on. So let me go ahead and share the Eclipse window here. What is that? Maybe if I click on this. Okay, here. All right. I don't know if you can see the Eclipse window. Can you?
Yes.
Okay. Yep. All right. Let me show you. This is the drawing program, and it has a bunch of packages, and you can see that it's very tiny. I know. I mean, I don't know how to make this bigger. There is a controller package here. Then there is a model package. There is a view package. On top of it, or not on top of it, in addition to it, there is a package called FX GUI. I could have named this GUI. It wouldn't have made any difference. And the GUI itself has sub-packages. let's arbitrarily open one of these. Okay. If you look at this public class open button, extends GUI button, etc. So you can see a lot of JavaFX code here. So there is you can see action event here, event handler, this handle method, they are all from JavaFX. Or if you look at handlers, I'm dealing with JavaFX. This particular part of the program is nothing but JavaFX. So what happens when a key is pressed? If it is backspace, do one thing. If it is escape, do one thing, something else, and so on. Then there are panels to construct the button side. So I have a button panel extends VBox. So again, lot of JavaFX code. And here I have the drawing panel where actually I draw the stuff. So this package is nothing but FX stuff. So that constructs the GUI, but, or maybe, let's do one thing. Let's look at something simple here. The line button. Line button extends GUI button. And if you look at GUI button, it extends the button class in JavaFX. Okay. When you click on the line button, you might remember that there was a button that had the word line, the text line in it. And when you click on it, control comes to this handle method. And what am I doing? There is a class called controller, which is a singleton, as you might imagine from here. And I am calling a method or invoking a method called onLine command. And this controller happens to sit in this particular package, this controller package. And if you look here, it has a sub package called commands, and the controller is actually in that. And if you look at stuff here, you wouldn't see a single statement, anything here that resembles JavaFX. There is nothing, it has nothing to do with JavaFX. So for example, when you click on the line button, we saw this a minute ago, and you click on it, control comes to this handle method, and we are calling the onLine command. That is, what do you want to do when the line button is clicked, when the line command is issued? We come here to this method and we say, okay, if there is no command in progress, we create a line command object, and that is our current command. And the line command object will respond to button clicks. How? Okay, before we see that, we should kind of take a look here. I have a method called onMouseEntered, but you don't see any code that deals with JavaFX. It doesn't know what technology is being used. All it knows is that mouse has been entered into the drawing panel. Or here, it doesn't know that a button was clicked. All it knows is that the user wants to draw a line. Or here it knows that the mouse has left the drawing panel, or that here it knows that a polygon has to be drawn, or here a character has been typed. It doesn't know how to handle that character typing. It knows that a character has been typed and this is the character and that has to be handled. Or the backspace key has been pressed. It doesn't know how to capture that backspace key press. That is done at the JavaFX level. Here we are saying, what should I do when the backspace is pressed? What should I do when I have to abandon the current command? That is actually indicated by pressing the escape key, but there is no notion of an escape key here. all we know is that there is a logical request to kill the current command. So this is independent of the exact graphical user interface being employed. Or we know that an undo, the current command has to, or the last command has to be undone. How do we do that? Or we need to redo an undone command, or that we know that a point has been specified. We don't know how that point was specified. We don't know whether the user typed it in or whether the user clicked. We don't know. So you can see that this is the controller really. I mean, at least part of the controller. It is at a very logical level. It has nothing to do with the actual graphical user interface. There is only input coming in. It doesn't display anything if you look here. It only handles requests. What should I do when the user wants to save data? It doesn't know that it was done through the click of a button. So there is no JavaFX code. Does that help a little bit?
Yeah. I mean, I can see it's doing more of kind of like routing.
Yeah, it is routing. And also notice that it has nothing to do with the interface itself. The interface can be changed at will, as long as this particular protocol is followed. That is, when an open request is made at the GUI level, or maybe it could be done by some other mechanism. I don't know what that will be, but you should call the on open request. That's the idea. Okay. So there is, yeah, sure. There is a bunch of stuff here. We will get to all that. So there is none of this has anything to do with JavaFX. And there is, maybe I'll go at a very high level for the moment. We need to do undo and redo. So how to do that is answered by I mean, the primary agent in that is this undo manager. Okay. It maintains two stacks. One is the history of all the things you did, and this will contain what are called command objects. And whenever a command is issued, we will put it into the history stack. And when a command is to be undone, we pop it and put it into the redo stack. So that is a quick look at this undo redo business. But you can see that there is a command class for every kind of big actions. When you want to create a label, when you want to create a line, when you want to open something, polygon creation, etc., we have command objects for every one of those. We will get to that in a few minutes. And then we have the model that is much easier to understand. You have seen this kind of stuff before because it is a collection. A model stores a list of shapes. It is a singleton. So you can add a shape. A shape is something like a line or polygon or label, or we can have other shapes also, maybe images and circles. You can remove stuff. You can get the list of shapes and so on. And then the last big thing here is the view. There is just one class here, which is the view, and it is a singleton, as you can see here. And you can draw using the view. What it will do is it will take every shape in the model and draw all of them, right? That is the plan here. So you can see, in summary, a controller package, a model package, and a view package. That is the MVC. But to provide input, we need a graphical user interface because we have a drawing program. So we need and we decided we will implement it using JavaFX. Okay, so that is our first look at the architecture and the program. What I want to do now is take a look at something that we already have in the lecture videos. I will go over some of those things here relatively quickly. So let me share the PowerPoint here, and then maybe I will show you some part of the code. I can't show you everything. It will take forever. So I don't want to do that, but I will show you some of the code, the representative code. It is not necessary to look at everything because some of those things are kind of similar across. It's okay here. All right. Let's go from the beginning itself, and then I will skip things very quickly, those that we already covered, right? So we already talked about the model view controller, and the controller is supposed to handle commands. And as the controller gets commands, it very often deals with the model. It inserts things into the model, it modifies things in the model, and sometimes it tells the view to do things. And whenever the model changes, the view is supposed to listen to that and show the data appropriately. So that is the interaction between model and view. The model is an observable and the view is an observer. So the model extends property change support, or it can have that would be a class adapter, or it can be an object adapter with property change support as a field, as the adaptee. And when you call the update view, when you call the update view of model, it will fire the property change so that the view is notified. The view observes the model, so it implements property change listener, and whenever the model changes, it fires the property change. So this method gets called, this method of view gets called, and the view can then refresh the screen. So the view is responsible for presenting things, the model stores data, and the controller handles the input. If you think of things that some of the things that you use on the web, they can be thought of as model view controller. For example, you might be going to an online store. All the product data that they have would be the model. The browser that you handle would be the graphical user interface through which you issue things like browse products or put a product in a cart or check out the products. Those kinds of things are handled by the browser. So browser is the GUI, and it sends those commands to the distant server where the controller will take those things and take those commands and then manipulate some objects in the model. And it will decide how to display all the information, and the browser will be the GUI to display that information. So an online store can be implemented using the MVC paradigm, and it often is implemented that way. Okay, the drawing program, we went through all this. We saw how to draw a line, and you can see that when the user issues the command to draw the line, it has to come to the controller somehow. The controller will create a line object and add that line to the model, and then one of the endpoints is specified. That endpoint is added to the line, and the view has to be notified at that point so that the view can display one endpoint of the line. And when the second endpoint is specified, you adjust the line, and the view is told again to display, because we now have the second endpoint, so the line is complete. Things don't have to follow exactly this way. It could be that the line is created only after you get the first endpoint. Okay, so there can be minor differences, but this is the main idea. So one thing we would like to do is to accommodate GUI technology changes. You should be able to replace the GUI technology without changing the logic that is behind the drawing program. So that is one of the things. So we are separating the GUI from the controller and the view. The input part of the graphical user interface would collect commands and send them to the controller, which is independent of the GUI technology. And that would be part of the logic, right? Here you will have the model and stuff like that. And the view will take the model data and decide what to display. It will invoke some commands that will eventually result in the shapes being drawn. So the question is, how do you structure the controller? One thing is that we want to separate the handling of the input at the technology level, at the Java FX or Java Swing or whatever technology you are employing, from the logic itself. The second thing is we want to support undo and redo. How do we do that? We are going to keep commands as objects. We are going to represent commands as objects. What do we mean by that? Well, when you draw a line, there are certain things that you specify. You specify that a line has to be drawn in the first place, and then you specify one endpoint and you specify the second endpoint. And after you specify the second endpoint, there is nothing more to be done because the line has been completely specified. So a line can be represented by a line class, that is a line object eventually. And that line object, if it stores the two endpoints, it has all the information necessary to draw a line. Okay. And there is nothing else that you need to repeat that line drawing whenever you want. That line can be drawn using this information, that is a line and the two endpoints. So we represent the whole thing by a command. A command can be executed. That is what you do when you actually click the two endpoints. You are executing that command. So that is one of the operations of a command. A second thing a command should be able to do is undo itself. And the third thing is redo. So here is the basic idea behind undo and redo. It is standard across all applications, the basic idea, and it is very easy to understand. Okay, how does it work? Suppose we drew a label. We create a label command object. It's not label object. This is a bit incorrect. This is a label command that you put on a stack. Now, suppose you draw a circle. Then the circle command is put on top of the stack. Then you create another label and then create another line. So we have 4 command objects here. Corresponding to these 4 command objects, the model will have 4 shape objects. These are all shapes. We said we had two labels, one circle and one line, and that is what we have here too. That would be the situation after 4 commands have been issued. And we have a redo stack that is empty. This is the history stack. Now, if you want to undo something, what we are going to do is pop the top of the history stack and push it onto the redo stack. So there is one fewer object here, and there is one object over here. So the line object has been, or line command object has been moved to the redo stack, and we will tell the line command to undo itself. How does a line command undo itself? It's very simple here. All you need to do is have that line command removed from the model. So this is the situation. At this point, the line command is out of the model, so it doesn't get displayed by the view. And when you want to redo, you simply put this back here. And in the process of redoing, the line command will add the line object back into the model. So the view will again get a chance to draw it. Take a look at this and see if you understand it. It is not a particularly difficult concept. All the things that can be undone are here. Whenever you undo, you pop it and push it into the redo stack and ask the command to undo itself. And when you want to redo, ask the command at the top of the redo stack to redo itself and push it onto the history stack after popping it from the redo stack. Questions? Okay. So a command can be, I mean, this would be the beginning of a class, public abstract class command with 3 methods. And the undo manager will have a history stack and a redo stack, as we saw. Stack of command objects. The command class is here, right? There will be many types of commands depending upon the set of commands you have. Whenever a new command is to be started, what we do is we clear the redo stack. Otherwise, you can get into inconsistencies. You can read the chapter that I have posted, and you can also listen to the videos to see. Actually, it is not in the video, it is in the reading only. There are some simple examples that you can create where if you don't clear the redo stack, you can be in trouble. And we remember that a new command has started by pushing into the history stack. When you end a command, you need to update the view. Undo, the pseudocode is this. If there is something in the history stack, you have to undo the command at the top and put it in the history stack, into the redo stack after popping from the history stack. Redoing is the converse. If the redo stack is not empty, pop the redo stack and redo that command and push that command back onto the undo stack. So it can now be undone if you want. The controller class will have commands to respond to creation of labels, lines, polygons. We saw this method already. The other methods are very similar. If there is nothing going on, if there is no shape being drawn, you start this new shape. Okay. But if you are in the middle of drawing a polygon, and if you click on a line, that line button to start a new line, you simply ignore that. If the current command is not null, don't handle this line command. You just ignore that request. And these are not all that important. This is to change the shape of the mouse. And here we have methods to handle things like mouse clicks or typing of a character. For example, here is what happens when a character is typed. If a command is in progress, let the command decide what to do with the character. The line command will ignore it. Polygon will ignore it, but a label will handle it, will use it. So if there is something going on, if a command is in progress, let the command know that a character has been typed. Let's send it the character. Let's see what it does with it. If a backspace is pressed, if there is a command in progress, give it to the command. It is up to the command to decide what to do with the backspace. Similarly, point input, cursor mode, everything depends on the command. The command can decide what to do with it. If the cursor moves when you are typing in a label, it will ignore it. But if it is a polygon, it will draw a line appropriately. If you are abandoning the current request, ask the current command to abandon itself, to undo itself. Because that command knows how to undo itself. Nobody else knows. So the abandoned request has to be given to the command so that it can undo all the things it did. And then we say there is no command in progress. On open request, we create an open command, and that actually opens the file specified here, and there is nothing else to do, right? That becomes the new drawing. And save does something very similar, except that it is now saving the drawing into this file. The model, as we saw, is much simpler. It just is a collection, nothing more. And the view is also not all that hard. All it does is it observes the model and draws everything it sees. But it doesn't have to draw everything. That can be a decision made. I mean, you could say, I will only draw the last 10 shapes. If you want to make that decision, that's fine. There can be a view that draws only the last 10 shapes. There can be a view that shows only rectangles. There can be a view that shows everything. So you can have multiple views of the same information. You probably are aware of it. You see it all the time in your Windows Explorer or the Finder on Mac. You can have multiple windows of the same folder. One can be showing the thing as a list, another might be showing the contents of the folder as a list of a set of icons, right? So there can be multiple views of the same information. Okay, now with this part, I will get to a little later. Before that, I want to show you the code a little more. You're taking a lot of time on this, but unfortunately, that is required. Okay. I need to share the code. Okay. Let's take the polygon. Actually, we saw the code for command somewhat. The command class has the execute method, the undo method, and the redo methods. I also added all the commands that come from the outside, like on right click, on cursor move, because a command has to handle all these things. What do you want to do when a character is typed, and so on and so forth. Let's look at a very simple command, the line command. What does the line command do? It extends command. So every shape has a corresponding command class. A line command remembers the current line or remembers one line. This is not really, I mean, you need it in a transient way, the number of points. When, okay, here, when a new point is specified, I capture it in a custom class called canvas point. And if number of points is 0, this is the first endpoint of the line. We begin a new command and execute the command. What does execution mean? When a new line command is created, that line is added to the model. So model.get instance.add shape. So this is the model object. Into the model object, we add this line. If it is not the first endpoint, the point that is coming in is the second endpoint. So we set it as the second endpoint, and the command is over. So we call the end command method of the undo manager, which will simply redraw the model. And we tell the controller that the command has ended. So it will say the current command is now null. And we also have a view update here. Redo will simply, or rather undo, let's look at undo. Undo will remove the shape from the model. If you ask a line command object to undo itself, it will simply remove the line object from the model. So the model.get instance is the model. Remove the line shape, which is right here, right? Every command remembers the corresponding shape. And when you want to redo that line command, it will simply call execute. Execute is here. It will add the line back to the model. This is much, this is to handle mouse movements. As you are, after you click the first endpoint, after you move things, this will draw the line so that you can see what you are drawing. So that is one example of a command object. The other commands are very similar in spirit. So I'm not going to go over them at this point, unless you have questions. And here is the, okay, the model. I don't know whether I showed you this. I think I did. It is a simple collection, and you can see that it is using property change support as an adaptee so that the view can be a listener to the model. So that when the model changes, we are going to fire property change so that the view gets notified. And here is the view. It implements property change listener so that it is an observer of the model. So when it is created, the view becomes a client, becomes an observer of the model. And when the model changes, the model notifies the view, and we come to the property change method, which calls update. And we have a little bit of FX code here. We will get rid of all this in the next version, okay? And we will call the draw method of this. So there is FX code here because I am depending upon a specific type of drawing panel. Actually, we will see some of that. We will see the basics of getting rid of this dependency in a couple of minutes, okay? And we call the draw method to draw all the shapes. We are getting all the shapes from the model and drawing them over here. You can again see that there is a dependence on the technology over here. So how do you get rid of that technology? That is the last topic that I want to do tonight. So to get rid of the dependence on technology in the view, this is what we will do. Okay. So here, how do you draw the shapes without depending upon the technology? Okay. Well, if you're using Java Swing, then you don't want code that uses Java Swing. And then if you switch to Java FX, you will be in trouble. You'll have to change all that code to Java FX. So how do you make your drawing of the shapes independent of the technology? Because the drawing technology will change. One way would be to have a new type of shape for every possible technology. This is not a good idea because there can be line, label, polygon, circle, blah, 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 lots of shapes. And for every shape, if you start creating separate classes, if you have 10 different shapes and 5 different technologies, you are going to have 50 different classes. This is not a practical way of implementing things. You'll be creating far too many classes. There will be class explosion. So we use a design pattern called bridge. The idea is not all that hard. We have a hierarchy here with a root class called shape. Line is a shape, label is a shape, polygon is a shape. If you add circle, that will be another subclass of shape. Okay, so we have a hierarchy of shapes. And we have lots of technologies. We had aught when Java came out first. Then we had Swing. Then we had FX. We might have a fourth one, who knows? So we could have many different technologies for drawing things on the screen. We don't want separate classes for every shape and technology pair. That we saw is not feasible. It is too much work. So what we are going to have is an abstract class here called a renderer, which can draw very basic things. For example, it has a method called draw to draw a piece of text at a specific point, or it can draw a line from one point to another, or it can set the color with different red, green, blue values. So you select a bunch of crucial methods that would cover drawing almost every shape that you can think of. So once again, there are 3 things I chose here. One is to draw a piece of text. Second one is to draw a single line. The third one is to change the color of the drawing. And I can draw a line, a label, and a polygon using a combination of these 3. For example, for drawing a label, I might change the color to something and draw the label using this first method. To draw a line, I might set the color using this third method here and draw the line using the second method. For a polygon to be drawn, I will set the color using this and then draw a sequence of lines using this. The polygon knows what vertices it has, and it can draw all the lines by passing in the 4 coordinates, the XY coordinates for the 2 endpoints. So there are 4 of them. right? So all you need to have is a render method in shape that will be overridden in each of these shapes. Every shape will say how to render itself. The view will simply tell the shape to render itself and give it the renderer from the corresponding technology. And it will be rendered using that renderer for the corresponding technology. So there is absolutely no dependence on the exact technology on the side of the view. I will post the solution for that next week, sometime this Thursday or Friday. I will post the quiz for next week also around that time, and also the lecture videos. So wait until possibly Friday for me to post all that information. Okay, it has been a long lecture, so I'm going to stop here. There may be still some questions that come to your mind as you are doing the class exercise. I will stop by and help you at that point. Okay.